So dear students, now we are going to discuss about the constant models and uh, LS constant model beamforming. That LS constant models beamforming is nothing but least square constant models beamforming. So now the first thing is, see here why we are using this constant models and the least square constant model is here we are using for adaptive weight, and it enhance the desired signal and also suppress the interference. So this adaptive beamforming can be trained based or training based or blind method. The next thing is, so why this constant models we record means, the many communication signal we have constant envelope. For example, BPSK, QPSK. So here we can do, we can we no need of the training sequence. We can enable the blind beamforming. The next thing is signal model. So first we should assume the input vector is x of n and beamformer output is y of n is equal to W Hermitian of x of n. So here we need to adjust that modulus of y of n is a constant. So the next thing is how we can create the criterion for constant model is the formula is see here, the cost function j is equal to e of modulus of y of n square minus r the whole square. So here that r depends on the modulation. For the PSK we can use the 1, and also we are forced the output signal to have constant magnitude. And the next thing is constant models algorithm. So here the blind stochastic gradient algorithm we are using. So how we are using this weight update, see here W of n plus 1 is equal to W of n plus u mu of x of n y of n into r minus modulus of y of n the whole square. The mu is nothing but average. So that way we W1 of is nothing but weight of the function, and x of n and y of n that input and the corresponding output function. So here we no need of no steering vector or training record. And what are the constant model techniques characteristics is, the first thing is we can blindly adapt it because here there is no training sequence. The next thing is the here the computational complexity is very low because we know the predefined data. The next thing is slow convergence, and the fourth thing is it suffer from local minima and phase ambiguity. So now we are going to discuss about the least square constant models algorithm. So it is a batch version of constant model algorithm only here, but we are using multiple snapshots. So it will be improve the convergence speed and also the stability. And here see here that's how we are modifying the constant model criterion here. The j is equal to summation of, we are using that formula, see that modulus of W Hermitian of x of in the whole modulus of square minus r into square. Just we are modifying that problem, that function here. That constant model we are using that sorry, without the summation function here we are using, and here we are using the we are using for non-linear least square problem. So here there is no closed form solutions. And what are the method here we are following means iterative gradient method we are following. So that is nothing but Gauss Newton or conjugate gradient. And the next thing is recursive LS least square constant model method. And also you are initialized with the conventional beamformer. And the next thing is, while we comparing this constant model algorithm and the least square constant model algorithm, so this constant model algorithm it is very simple and low complexity and low convergence, and but this least square convergence method it is a faster convergence and higher complexity. Both are blind forming techniques, and this is the one method of this constant models method. So we see here we are desired direction main beam we are using. So undesired direction and all we have to nullify. So that signal will be adaptive beam forming algorithm we are using. So in that we have to select whether we are doing the constant models or least square constant models. So the output corresponding output will be, see that end of the diagram we have the y of k and e of k and d of k. So based on that only that summation that will be automatically, that summer circuit will be adjust the signal and it will be provide the desired output signal. So what are the application means we can use for smart antenna receivers and wireless and mobile communication, satellite communication system and interference suppressions without training. Thank you.